All right, hi and welcome to another installment of Math Basics with Mr. Besh. Today what we're going to do is use our prior knowledge and skill to solve algebraic applications using plane geometry. What I have is I've selected two example problems from a sheet we've done in class, and I want to walk you through this step by step. Now, here's the first one. This was question number 4 from the sheet. Before I begin, let me preface this. Our model here, the two parallel lines are M and L, the transversal cutting through is T, will be the same exact model for each and every problem that we do in this unit. But when I find the measure of angle 1 and 6 upon the completion of this problem, I want you all to know that those values, 1 and 6, are not the same values for questions 5, 6, 7, and 8. Each problem is independent of one another. Okay? So this is what I need to do. What I know in question number 4 is that the measure of angle 1 is 4x plus 9. And I also know that the measure of angle 6 is 2x plus 3. I take a look at my picture where I look at angle 1 and I look at angle 6. Angle 1 clearly is an obtuse angle where angle 6 is an acute angle. I know from my model that angle 1 combined with angle 2 make 180 degrees. And from my vocabulary, I know that angle 2 and angle 6 are congruent by definition of corresponding angles. Angles in the exact same spot, but on two different lines. So because I know angle 2 is the same value as angle 6, that means that angle 1 and angle 6 combine together to make 180 degrees. They're supplementary. So now, to do my algebra, what I do is I take my first angle, which is 4x plus 9, and I add it to my second angle, which was 2x plus 3. Altogether, it equals 180. And then I combine my like terms. 4x and 2x add together to make 6x, and a positive 9 and a positive 3 combine together to make 12, and all that equals 180 still. Then I got to subtract 12 from both sides, just solving it like a normal two-step equation, and I get 6x is equal to 168, and last but not least I divide both sides by 6. Finally I get x is equal to 28. Now don't jump up for joy because we're not done. We got to answer the question. The value of x is equal to 28. So now we take this value here for x, and we need to substitute it in for each of the angle measurements. Now we know, and there's always shortcuts, angle 1 and angle 6 add up to be 180. So now I take 28 and I put it in here in place of x. This means 4 times this plus 9. So 4 times 28 is going to give me 112. And then when I add 9 to that, I get 121 degrees. And that is the value measure of angle 1. Now, the measure of angle 6 is 59 degrees. How do I know this? Because these two have to add up to be 180. So 180 minus 121 will give me 59 degrees. I could have also come back up to here where it says measure of angle 6 and put a 28 in there for x. So 2 times 28 would give me 56, and then 56 plus 3 would make 59. And this is what happens in my example or model when my two angles are supplementary to one another. The next example I want to do is when the angles are congruent. You see, same thing exactly as before, but now we're talking about angle 2, which is acute, and then we have angle 4, which is also acute. Now we know from our vocabulary that angle 2 and angle 4 are vertical angles. And by definition, vertical angles are angles across from one another, either horizontally, vertically, or diagonally. And they're in the same spot, and they're the same value, and they're congruent. So now we know angle 2 is equal to angle 4, the measure at least. So what we're going to do is we're going to take that value of measure of angle 2, 11x minus 4, and we're going to set it equal to 3x plus 28. What happens is we get a different type of an equation. If you remember, and this is why I stressed about our prior knowledge in solving equations. We've done that months ago. Now we have an equation where we have a variable on both sides. Notice I took each expression, each angle, and put them equal to each other. My first step in solving this equation, get rid of the x term on the right side. It's positive 3x, so I have to subtract 3x from both sides. Minus 3x here gives me 8x. Minus 3x here leaves me with just plain old 28. Now, it's a simple two-step equation. Get rid of the minus 4 here by adding 4 to both sides. I get 8x equals 32, and last but not least, divide both sides by 8, I get 4. Now remember, once I get the x value, x comes out to be equal to 4, now I need to substitute it into my values. Remember, they're congruent to one another. So if I do one, I don't have to do the other unless I want to check my work. So now I got 11 times 4, which gives me 44, and then take 4 away from that gives me 40 degrees. So the measure of angle 2 is 40 degrees, and because they're congruent, the measure of angle 4 equals 40 degrees. But if I wanted to go and check my work, I take that 4 again, I plug it into this. 3 times 4 makes 12, and then 12 plus 28 does again give me 40 degrees. So that's how we do an example using our algebraic expressions if my two angles are congruent. So to rehash this, we did 2 examples where 2 angles were supplementary and then 2 angles were congruent. Ladies and gentlemen, I hope you find this helpful and informative.